Hello guys, welcome to Ramta Solutions and welcome to your grade 11 Analytical Geometry. Today we're looking at parallel and perpendicular lines. So without any waste of time, in this video we're going to look at parallel lines separately and perpendicular lines separately. At the end of each theory or whatever nodes on these lines, we will give you worked examples. Okay, so without any waste of time, let's get into it and see how it goes. And by the way, I need to remind you guys that these you covered as well in grade 10. All right, these you covered as well in grade 10. But let's proceed either way. So let's begin with parallel lines. Okay, let's begin with parallel lines. Now, regarding parallel lines, if you recall, we said parallel lines have equal gradients, right? We said they have equal gradients, right? They have equal gradients, right? So, an example we gave you was, let's say you have these two lines. Let's say this is line 1 and this is line 2, or whichever you prefer. Alright, it doesn't matter their gradient. As long as they have the same gradient, they will be parallel. So, pay attention to these arrows. These arrows are representing parallel lines. Okay, these arrows are representing parallel lines. So as you can see from here, we are basically saying gradient of line 1 is equal to gradient of line 2. Remember, though they have equal gradients, they do not have the same equations. So note, their equations are not the same. Okay, their equations are not the same. Okay, the equations are not the same. By saying they have equal gradient or similar gradient does not mean that their equations are the same. All right, happy? Cool. So now we're going to try some examples. So let's begin with example 1 on this. So I'm going to call it example 1 under parallel lines. Let's say are the following parallel. All right, are the following parallel. Roman figure 1, y plus 2x equals 1 and minus 2x plus 3 equals y. Roman figure 2, we have y plus 1 equals x and x plus y equals 3. Okay, now let's get our answers. Number 1, we have y plus 2x equals 1, which we can rewrite as y equals negative 2x plus 1. And then here we have negative 2x plus 3 equals y. We don't have to do anything. By the way, guys, if you are one of those who say they prefer your y's to be on the left hand side, this is what it means. As you can see, I didn't change anything. It's still the same. Okay, it's still the same. Okay, y negative 2x plus 3 is equal to y is the same as y is equal to negative 2x plus 3. So check this out. What is the gradient here? Gradient here is negative 2. What is the gradient here? Gradient here is negative 2. So these ones are parallel. All right, these ones are parallel, isn't it? These ones are parallel. Okay, now let's check number 2. Number 2, we're looking at what is it? It was y plus 1 equals x. Y plus 1 equals x. Let's look at it. This is y equals x plus 1. And we also had x plus y equals 3. This is similar to y equals negative x plus 3. What is the gradient here? Here the gradient, which is the coefficient of x, is 1. What is the gradient here? The coefficient of x is minus y. Therefore, gradients are not equal, right? So M1 is not equal to M2. Therefore, we can say not parallel. Okay? Okay, not parallel. Let's call this one M1. Let's call this one M2. Okay? So these ones are not parallel because their gradient are not the same or are not equal. Isn't it? Perfect. So this is it, guys. This is all that we need to know about parallel lines. But hold on. I'm going to try another example. So example 2 under parallel lines. We will try, let me see, what should we try? Okay, let me try this one here. It says, determine the equation of a straight line that passes through, let me write that. Determine the equation of a straight line that passes through the point 1 minus 5 and is parallel to, let's see, and is parallel to y plus 2x minus 1 equals 0. So our solution, let me highlight important parts of this question. Important parts of this question are: one, you determine the equation of a straight line that passes through this and is parallel to this. These are the key factors, right? So what we need now, our solution, we will say, first thing first, y plus 2x minus 1 equals 0 can be written as y equals negative 2x plus 1, right? This is gradient line 1, okay? So gradient of line 1 is negative 2. This is also equal to gradient of line 2 because they said the lines are parallel, right? Therefore, so now finding equation of that parallel line. So finding equation of the parallel line, what do? We will say, because we already have the gradient, we will use gradient point form. So we will say y equals mx, let's use, not gradient intercept. Y minus y sub 1 equals gradient into x minus x sub 1. So this is the gradient point form, okay? We're using this because we don't have the y-intercept of line 2, isn't it? Perfect. So now, proceeding, we have the point 1 minus 5, right? Where there's x, we will put 1. Where there's y, we will put minus 5. Where there's x1, rather, we will put 1. Where there's y1, we will put minus 5. So this is y minus 5 equals, what was the value of the gradient? It was negative 2. Can you see it? Remember we said the equation of the straight line, or rather the straight line that we're looking for, its equation is parallel to this straight line here. All right? So we found that its gradient is negative 2. So proceeding, it is negative 2 into x minus x sub 1 is 1, right? So this is y plus 5 equals negative 2x plus 2. Therefore, we can say y equals negative 2x minus 3. Minus 3. Isn't it? Minus 3, right? So this is it. This is your equation of the line that is parallel to what? Of the line that is parallel to y plus 2x minus 1 equals 0 and passing the point 1 minus 5. Right? So this is the equation. All right. Now, we are heading to perpendicular lines, we are heading to perpendicular lines. So two perpendicular lines. So perpendicular lines. Remember, whenever you hear perpendicular, you must remember 90 degrees. All right? Remember, with these ones, they form a 90 degrees at point of intersection. All right? At point of intersection. All right? And two, gradient of 1. So this is a revision of grade 10 basically. Gradient of 1 is the reciprocal, is the negative, in fact, is the negative reciprocal. Is the negative reciprocal. Can I no. Is the negative reciprocal of the other. Okay. Is the negative reciprocal of the other. Okay. Remember, highlight that they form 90 degrees at point of intersection. I'm going to give you an example. So let's say this is line 1, this is line 2. Okay? So these are perpendicular. Now, if they are perpendicular, remember here we said gradient of 1 is the reciprocal of the other. This therefore means the product of the gradients, or of their gradients, is -1. Okay, what does this mean? This means gradient 1 multiplied by gradient 2 is equal to -1. Okay, gradient of line 1 multiplied by gradient of line 2 is equal to -1. So this is important to note for perpendicular lines. Okay, this is important to note for perpendicular lines. Now let's try examples. Now examples under perpendicular lines, proceeding. Example 1, under this, I will say, are the following perpendicular. The following lines perpendicular. Right, are the following lines perpendicular. Now, we're looking at Roman figure 1. We're looking at y minus 1 equals 4x and 4y plus x plus 2 equals 0. Roman figure 2, we're looking at y minus 2x equals y, and the line passing through, point 2 minus 1 and point minus 1, 5. Right? Right. Now our solutions. So for example 1, or question 1 of this example, we have 1 minus y minus 1 equals 4x. This could be written as y equals 4x plus 1. And here we have 4y plus x plus 2 equals 0. This could be written as 4y equals negative x minus 2. Dividing by 4 throughout, this will be y equals negative 1 over 4x minus half, because 2 over 4 is 1 over 2, isn't it? It's 1 over 2. So when you look at these gradients, so let's say this is line 1 and this is line 2. When you look at these gradients, this one is 4, this one is negative 1 over 4. Remember what we said? I said gradient of 1 is the negative reciprocal of the other. So they are perpendicular. right? They are perpendicular, right? They are perpendicular. Can you guys see that? If you guys are not really sure how we got to this, you can still say gradient of 1 multiplied by gradient of 2. What is it? It is this one here, it's 4, as you can see, coefficient of x. And this one here is negative 1 over 4, as you can see. So what is your answer? Your answer is negative 1. Remember, he said if lines are perpendicular, the product of their gradients are equal to negative 1, right? Product of their gradient is negative 1. So therefore, these two lines are perpendicular. Okay, perfect. Now, Roman figure 2, we have 1 minus, let's hold on with that. We need a gradient of the line passing through point minus 2, 2 minus 1 and point minus 1, 5. So, now, what we need, we will say gradient is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. What is this? This is 5, let's see, 5, it's 5 minus 1, okay, 5 minus 1, and then it's minus 1 minus 2, okay, minus 1 minus 2. Therefore, what is our gradient? It is 6 over 3, so it's basically negative 2. It's basically negative 2. Happy? It's basically negative 2. So I'm going to use gradient point form. So it's going to be y. Now, equation of line, what is it? Equation of line, let me just write it like that. Now, equation of the line will be y minus y sub 1 equals gradient into x minus x sub 1. So the point that I'm going to use, guys, you can use any of these 2 points. I will use this one, 2 and minus 1, okay? So 2 minus 1, this is the point I'm using. Whether it's x1, you put 2. Whether it's y1, you put minus 1. So this is y minus 1. And what is our gradient? It is negative 2. What is, okay, x. What is x sub 1? It's 2, right? So this is y plus 1 equals negative 2x plus 4. So this is y equals negative 2x plus 3, isn't it? This is negative 2x plus 3. Remember, let's call this one line 2, okay? Now, you remember gradient of line 1, okay, for line 1, the equation was, what is it? It was y equals 1 minus 2x. Can you guys see that? It's y equals 1 minus 2x. Guys, 1 minus 2x is the same as minus 2x plus 1, okay? So what is line 2? Oh boy. Now, why am I using lime? Now, line 2, what did we find? We found that x equals, let me see, negative 2x plus 3, all right? So here, as you can see, gradient of line 1 is equal to gradient of line 2. Therefore, these lines are not perpendicular, right? These lines are not perpendicular. How are they? Parallel, isn't it? These ones are parallel. Can you guys see that? These ones are parallel. All right. So this is how we roll, guys. This is basically how, this is basically it. Okay. So remember, if you also are not sure about this, you can also do this. You can say, oh, gradient of line 1 multiplied by gradient of line 2. What is it? Line 1, gradient is negative 2. Line 2, gradient is negative 2. Negative times negative is positive. So this is for this is not perpendicular. All right? But because these gradients are similar, we can say they are parallel. However, you don't have to say that. The question was saying, are they perpendicular. So your answer is no, they are not perpendicular. Okay? All right. So, all right, guys, this is it. Now, if you want to get in touch with us, you can email us or you can visit our website at www.ramtasolutions.co.za, or if you want to email us on the very same website, you will find these icons at the bottom. All of these icons are there in addition to WhatsApp icon. So you can use this icon to email us, and you can, of course, subscribe to our YouTube channel. You can also share this video with your friends and your classmates. You can also follow us on your social media platforms. And if you like, on the very same website, there is a WhatsApp icon. When you click on that WhatsApp icon, if you are watching this video using your mobile device, it will open your WhatsApp and you can send us a message and chat with us. Of course, if you're in need of a tutor, you are still at the right place. So, with that being said, guys, ours ends here, and I hope you ace your exams. This was the last video of your grade 11 analytical geometry. So with that being said, it's a wrap, and bye-bye.